Hello and welcome to the last lecture of the string section. In this lecture, we want to talk about interning in a string. String interning is a process where multiple string instances with the same content are optimized to share the same memory location. This means that instead of having multiple separate instances of identical strings, the runtime ensures that only one instance is created and shared among all references to that particular string. For better understanding, let's illustrate what happens when we declare string literals. As you know, when we declare a string variable, such as myString1, two memory locations are allocated. But what we haven't mentioned is that internally the CLR maintains an interpool table which stores a single instance of all unique strings. In this case, the CLR stores the memory address of this string object in the interpool table. From now on, whenever a string with a value of Hello John is created, although its object is initially created in memory, the CLR recognizes that a string with the exact same value already exists. As a result, the myString2 variable points to the same memory address as the myString1. A little later, the duplicate string object is removed from the memory. Now, let's jump into VS Code to verify this scenario. Here, we have two string objects. We can verify a string interning by utilizing the reference equals method from object class. This method accepts two reference type variables as parameters and returns a Boolean value. If both variables point to the same memory location, it returns true. Otherwise, it returns false. Next, let's display the result in the terminal and run the application. As you can see, the result is true, which means the myString1 and 2 point to the same memory location. Alright, so far we've directly assigned the value of Hello John to variables. Now let's explore what happens when we dynamically assign this value to a variable. To begin, we'll declare two string variables. Then, let's declare another string variable to concatenate these two variables. Now, the value of myString5 is Hello John, and based on our understanding of the interning process, we'd expect the myString5 variable to point to the same memory location of the existing string object with the value of Hello John. However, since we assigned the value to the myString5 dynamically, it doesn't undergo the interning process and instead has its own separate memory location. Let's verify this using the reference equals method. As you can see, we get a false as a result. This means that the references of the myString1 and 5 are not equal, despite both variables having the same value. Of course, we can manually control string interning with the intern and isInterned static methods. The intern method is used to explicitly intern a string. For example here, since we directly assign the value of Hello John to the myString1, the string literal is automatically interned by the CLR. But because the myString2 is created dynamically, it isn't automatically added to the interpool table by the CLR. So, to explicitly intern the myString2, we use the intern method. When we call the intern method on this string, this method searches for the specified string in the intern pool table, and as expected, it successfully locates the specified string in the intern pool table and returns its address. As a result, these two string objects point to the same memory location. A little later, the duplicate object is removed from the memory. Now, let's show you the scenario where the intern method doesn't find the specified string in the intern pool table. In this example, when MyString1 is created dynamically, it isn't automatically added to the intern pool table by the CLR. Therefore, when we use the intern method and pass MyString1 to it, this method doesn't find any string with a value of Hello John. As a result, the intern method adds the string to the intern pool table and returns its address. And as you can see, both of these variables refer to the same memory location. Now, let's show you the intern method in action. Let's pass the MyString5 to the intern method. As you can see, this time we get true as a result. This means that, unlike before, now MyString1, 2 and 5 all point to the same string object in memory. Alright, now let's discuss the isInterned method. This method searches for the specified string in the intern pool table. If the string is already interned, a reference to that instance is returned. Otherwise, null is returned. In this case, when we use this intern method and pass the MyString1 to it, this method doesn't find any string with a value of Hello Emma in the intern pool table, and as a result, it returns a null value. However, if we directly assign the value of Hello Emma to the MyString1, like this example, and use this intern method, this method successfully locates the string in the intern pool table and returns its address. The key difference between intern and isInterned lies in their behavior when the desired string is not found in the intern pool table. In such cases, the intern method adds the string to the intern pool table and returns its address, whereas this intern method simply returns a null value. Alright, in summary, string interning is an interesting feature but not commonly used in practice. Misusing it can degrade application performance, so it's recommended to consider string interning only when creating many strings with identical content. Okay, done. See you in the next lecture.